One of the problems that I found doing an LT1 swap, which some people also find in some of the LS swaps, is that you need to remove the vehicle anti-theft system, which is also referred to as the VATS system. So, unfortunately, in a 96 LT1 Corvette, the only real option was to disable it via the actual program inside the PCM. So there is several ways of doing it. You can ship it out, have somebody do it for you. Costs anywhere between $100 to $200. If you invest enough, they'll even do some tuning for you if you are changing the tires or the transmission, yada yada. Somebody else does it for you as long as you present enough information. Well, I wanted to do as much hands-on as possible, so I had to purchase the software, which is well, I'll talk about that in the next video. But I had to get the software, and then I had to figure out a way to connect it. So first and foremost, you need to make sure that your OBD2 port is functional. Now, the car is still being put together, but I wanted to make sure I did the programming on it. So I realized that I could create a desktop or benchtop solution for it. So if I'm looking at this correctly, this is the OBD2 port or the data link connector, which uses the technology for the OBD2 port, is simply a matter of connecting wires between the PCM and this connector and between a ground and a power source. So what I did is I went through all the pinouts and I had seen an example before for an LS, and I thought, you know what, why can't we do this on the LT1s? So this is the spreadsheet where I actually put all the grounds together. Now let's start with the actual service manual snapshot that I took. As you can see here, this shows the PCM, and all these little squares here are actual pinouts that come from the PCM. So D30 or connector D, which is the last one, you could call it connector 4 or connector D, has pins 30 and 29, which splice together, go through the connector 238, go out somewhere out here, and then connect to pin 9. Okay, so those are two wires that need to be connected. And then here is D7, just as another example, goes through connector 238, then comes to 2. And this is, if you're doing it in the vehicle and you're going to put the OBD port, whether it's in the engine bay or in the cabin inside, these are the wires that you need to look for or extend to where this port is. Well, I'm doing a benchtop solution so that I can remove the VATS. And I kept reading how the LT1 computer, because it's slightly older, can take 3 to 7 minutes, 3 to 10 minutes to reprogram or to add whatever modifications you made back onto the computer because it's a little bit slower. And the number one warning is make sure you have enough power in your battery. Make sure that you don't lose power. Some people, I've seen some videos where they're actually connecting like a power source to the battery, like a jumper, to make sure that they don't lose connection. Because if you go under like, I don't know, 12 volts, 11, 10 volts, there's like a magic number. You could brick your PCM. So I thought, I see the LS guys doing it. I think the LT1 will do it as well. So I use these pinouts to create that harness. And after this, I'll show a video that I recorded several weeks ago. So I apologize because I'm jumping around. Some of the videos may actually repeat themselves. Bear with me. So again, if you go into the service manual, you'll get this information. So I translated it to here. So I grabbed my blank DLC connector here, and I said, these are the wires that I need to connect. I then invested in a 12-volt power supply, which is going to be like my battery, and it feeds this connection here. And then the ground wire that I have from this power supply, which again, I'm going to be doing it in home, feeds these ground connections here. So I connected it. I went to the red connector, and well, let me start over again. I went to the junkyard and I found another LT type engine and I pulled these 4 LT connectors. I then depinned them and then I ran my own wires. So on The red connector, C1 or A, notice how down here these are labeled D, because this D is going to be this fourth one. So I grabbed the red connector, I pulled them all out, then I went to pin 2 and pin 18, according to the service manual, and these are PCM grounds. So, you need to have enough grounds for it. And you have these two, which is circuit 451. Then on the clear, yes, I'm going to jump that one. Then I went to the clear connector or gray connector and pin 32. Again, this is completely clear out. And then pin 32, I ran a ground cable. And then in the blue one, here's my last ground cable. So there's 4 ground connections that you need to make. The other 2 are going to be directly to this DLC right here. So altogether, the circuit, you have 1, 2, 3, 4 wires or pin wires that are coming out. We'll act like the ground source are here, and then you have another 2 coming directly from the data link connector, and these guys all connect to my ground source. And again, it'll make more sense when you see the video. All right, so those are the grounds. Then I came through and I said, okay, how many power feeds that I need? Now, the way the OBD2 works is it's got direct and ignition power. The direct ones, which are listed as battery feed, have a constant 12 volts always going to them. So here we have a red wire and another red wire, which are direct battery feeds. And then here, actually that's ignition run. Okay, so we're gonna leave that alone. So you have 2 wires that when you're in the car are always receiving a 12 volt connection. Then you have ignition feed wires. These are the ones that activate the actual circuit and allow you the PCM to turn on and provide power to this port so that it allows you to do whatever programming you need, whether it's pulling the information of the fans, or in my case, this allowed me that when I turned the key to run, this would have allowed me to connect to the PCM, remove VATS, and then send the program to the PCM. So since, and again, the video explained, since I'm not going to install a key, what I did is I connected this ignition source, these 3 from the black connector, which is all power, and this pin on the DLC, all to my power source. And so the way it's going to work is when I connect my adapter to the wall, I connect the terminal to this little harness that I made, and that mimics the key turning on. So that makes it look like the key's turned on and all 4 of these pins, 5 of these pins are receiving power. So again, we went over the grounds, and then these are ignition feeds. Now, how do we get data over? I wasn't able to get a direct confirmation on which ones provide the magic here, but I know that they are all coming from the blue connector or C4, or see here, it's going to be the D. But these pins, these last pins down here, are the ones that carry the data over depending on with your programming. Now, I do know that the 2 main ones are pin 7, which is a purple wire, and pin 29 and 30, which actually, if you notice here, 29 and 30 splice together and come into pin 9 down here. This guy loops all the way to 9. So since it's tan, I created a tan error, and I'm like, okay, pin 9. And these are already spliced together in the harness. You just have to locate this terminal, this wire here, and then connect it, solder it into the here. The purple wire goes to 2. And again, I wasn't able to get a direct confirmation as to which one is the serial port connection and which one uses the direct connection that the USB takes advantage of. So I just connected them both. I have a feeling if you figure out which one does what signal, you only have to use that one. So that I wouldn't have to bother with that, I connected them both because whichever one's active at the time of connection is the one I'm going to use. So after a while, I was like, it's only 2 wires. They can both be on. Okay, so that's where the actual programming happens. This is what downloads your information and also programs the information back onto it. These are the wires that also when you're sending information, this is what also allows you to receive information like error codes that you're getting. Okay. The last one is this output field service. This is another connector that has to be on for the OBD2 96 LT1. And this is another wire that helps with some of the connections and the data information that's being relayed to you. Not going to touch on that. That's beyond the scope of this video. But just understand that these last four wires here, they turn into three: purple, tan, and white. But these are the wires that actually control the data out and in from the DLC connector or the OBD2 port to the PCM. All right. So now that I've showed you the spreadsheet and the raw data, as it were, I have a video that I recorded, and I show the actual device creation. And sorry to use the term again, but the raw device that I use, because uh, the video will make more sense. But anyways, thank you for watching. Upcoming, like I said, is the device that I created, the benchtop solution that I use so that I could do the programming to remove the VATS inside, since the engine wasn't built correctly. And that way, that was just one less thing that I was going to have to worry about. I've also wanted to get into tuning, so this allowed me to start looking at the data and seeing what fields I can manipulate, so that little things like the size of the tires, the O2 sensors, the radiator fans. I'm able to control that so that the swap goes a little bit smoother. All right, so I hope you enjoyed the upcoming video. Thanks for watching.
All right, so not sure what order I'm going to be presenting this, but here is the Jet. I don't know if you can kind of see there, but it's the Jet Performance, the Dynamic Spectrum Tuner, DST. There's a history on that. I won't cover it, but this is what you would use to be able to download your PCM's information and make some manipulate the tables or settings, and then this is what you would use this also to put all the information back on the PCM. As I probably mentioned when I was displaying the diagram, and forgive me, I'm not sure what order I'm going to be presenting this, so if I'm doubling up again, most of my videos will, so sorry about that. But so you would normally take this into your car, plug it in to the DLC or the OBD2 port, plug this into your laptop, make sure you have enough battery power, turn the ignition to run or accessories, however it works, and then download whatever program changes you made, or vice versa, upload to your laptop using these cables the information you need. So what I did was I kind of looked at all the different cables, or excuse me, all the different connections. I can't be the only one that's thought of this, but I'm presenting what solution I found. So what I realized is I just needed a constant 12-volt power. So here is my constant 12-volt power. Here's the connection for it. And what I did is, you're going to see the diagrams, and these are the only connections that you need on the OBD2 port. And on the swap, these are the only connections that I'm going to have on there. And this is what's going to connect directly to this guy. There. So then I had to go through all the wiring, or the PCM pinouts, and find where everything was coming from. Now on the red and the white, and again, I'll show on the diagram, all you really need is these three ground connections, 1, 2, and 3. The diagram will be specific as to which ones. That's all you need on this side. And then when you come over here, that is where it gets a little bit more detailed. You really have to kind of know, even though it's just 3 wires, these 3 wires, which are on the black connector, are going to be battery feed and ignition feed. I believe this pink one right here is the actual ignition feed. So this is the one, sorry about that. This is the one that when you turn the key, that's the one that tells the PCM that it's on, sends the actual power to it, and allows you to actually do the programming. So that one is kind of pretty important. Then on the blue, the other 2 are just power feeds. In other words, just 12-volt power running to them. On the blue one, this is where you have the majority of the connections, and you're going to have a ground, another ignition feed, which is, well, we won't touch that. Then you also have the serial data, or the actual class 2 connections coming to it. You have 2 that actually join to 1 connection. Then you have what is called the output field service pin that you do need. And then you have the 2 TAN serial data ports. So you have the UART or UART, and then you also have the class 2. The diagram will cover it more, but just kind of give you an idea. So what I did is I just ran everything like they're supposed to. Like if they were, you know, this would be in the engine bay, and that would be a little mini harness running to it. There's the power connections. It's in yellow because I wasn't sure if this was one, not only gonna be functional, and 2, if I was gonna keep it this way. But I'm probably gonna create a little mini harness here just to clean it up and make it better. So again, when I was using this, since the ignition key and the battery are just 12 volt, I connected them all to this power source. So this connection here mimics the turning of the key and the power. And then this is also the ground. So this feeds all my grounds. This is all my power. And I've tested this. I was able to use this on the software. I was able to remove VATS because of this and handle the programming. You know, you got to do your research. I'm going to present what I did. There's other solutions out there, I'm sure. Before the USB option was available, you would actually have to use a serial data cable. So there's an option if you're going to use it via serial data. But this is very functional. Now, this only works for the pinouts on a 96. If you were using a 95 or a 91 through 95 LT1, you'd have to make sure that you had the correct pinouts and the Create OBD2, as this is, sorry, the Create DLC connector. This is OBD2. You'd have to switch to either a 12 or a 16 pin, depending on what connector is. But this works. Like I said, I was able to remove VATS, been able to verify all the settings on my PCM, and I didn't have to worry. One of the things they tell you, especially on the LT1s, is don't lose power. Make sure your battery's charged. This avoids me having to worry about that because this is continuous power. And again, this did work. So yeah, you know, and just to kind of show something else for you LS swap guys, I saw somebody using this. Actually, my brother was using this to program, and I noticed on some of the LS swap videos when we were using it for reference, they were using this. Look at this. Look at these guys. These LS guys. 4 pins only. You bastards. And that's pretty much it, because that is a similar advantage. This is something you can actually purchase online. This wasn't made, but still, because of that, I started researching and realized, why can't we do it on the LT1s? And you can. So there you go. And then just use this alongside with the diagram video to kind of give you an idea of what you can, or, you know, what you can do. It's up to you. Thanks for watching.